Okay, you guys are doing okay? On lab assignment, you have actually 2 assignments which will be due on Sunday night. This morning, I didn't give the quiz in my other section, and so I wouldn't give you the quiz today. The reason I didn't give the quiz in the morning section was that I kept talking and I forgot about the time, and they actually were. You know how I realized that I forgot? I heard some people were smiling and laughing, and then when I realized that it was already almost only 5-7 minutes left, so they knew, but they didn't remind me. Okay. Here's what I'm going to do is start with one example, and this would be another example where you have a function not having a derivative at a point. So here's, let's say the function f of x is x to the 2/3, and so let's look at what's the derivative of this function at 0. These guys, the limit at 0 would be given by the limit as x goes to 0 of f of x minus f of 0 divided by x minus 0. And because f of x is x to the 2/3 and f of 0 is 0, I get x to the 2/3 over x, and that's the same as the limit as x goes to 0 of 1 over x to the 1/3. Okay, so what is that limit? What's the limit here as x goes to 0? Well, the problem is as x goes to 0 from the right, the denominator is positive, but when x goes to 0 from the left, the denominator would be negative. So basically what happens is that the limit as x goes to 0 from the right of this guy would be positive infinity, and the limit as x goes to 0 from the left of this guy would be negative infinity, right? Either way, I mean, the limit doesn't exist, so f prime of 0 does not exist as a number, so the derivative doesn't exist as 0. Since the limit doesn't exist, it means that the derivative doesn't exist. Now let's see what happens graphically. In this case, well, I told you how the graph looks like in the case we have actually 1/3 last time. So when you have actually 2/3, the graph looks like the following. And so the graph looks like this. It's actually symmetric about the y-axis. Okay, I don't know if I made it worse or better, or okay. But the point is, let's take a point on the right here. If you look at the slopes or slopes at the points on the right side of the y-axis, the slopes are getting bigger and bigger. Okay, and what it means is that the tangent line at these points are becoming, as you move towards 0, the tangent line is becoming vertical. Okay, and same thing happens here. As you move towards 0, the tangent line is becoming vertical again. Okay, so notice that the slope of a point on the right side is positive. The slope of a point here is negative, right? Okay. And you can see also. I guess I didn't tell you what's the derivative of this guy is. In fact, if you compute the derivative function, what you're going to get is 2/3 times 1 over x to the 1/3. So what I'm saying is that this is the function that I had, x to the 2/3. If you take the derivative of this function, you're going to get 2/3 x to the 2/3 times 1 over x to the 1/3. And notice that the derivative is negative when x is negative. Derivative is positive when x is positive. And so as you move to 0 from the right, the derivative becomes large, infinity, right? As you go to 0 from the left, the derivative becomes negative large. Okay. Again, you have a sharp point at 0 in this case as well. There is a sharp point at 0, and the derivative doesn't exist there. Any questions on that example? So this, the last 3 examples that I did in the class, they sort of gives you some idea what happens when the derivative doesn't exist at a point. So that sort of finishes section 2.2. And those of you who are disappointed so far because you haven't seen the formulas that you could use to find derivatives, well, that's what we are going to start now. So we are going to now look at the differentiation formulas. So differentiation formulas, and the first one. Before I give you the first formula, let me show you a couple of examples. If I have the function f of x equals to x, what's the derivative of this function at x? Well, without doing any type of computation in this case, let me just say that the graph of this function, we know it's a straight line. And the graph looks like, let's say, this straight line here. So this is the line y equals to x. And we know that the derivative at a point gives you the slope of the tangent at that point. Now, if I give you any point on this line, what's the slope of the tangent at that point? 1. Because every tangent is basically the same as the line, right? So in this case, we see that the derivative has to be 1 at every single value of x. Okay? Just by looking at the interpretation of the derivative as slope. So I won't bother computing the limit definition for this function. Let's look at f of x equals to x squared. What's the derivative of this function? Well, this time it's a parabola, so I cannot really say this. I cannot tell you what the slope is by what we did before. But let's just take the limit as h goes to 0 of f of x plus h minus f of x divided by h. And if we do that, what are we going to get? This would be the same as the limit h goes to 0. What would be f of x plus h? It would be x plus h squared minus x squared, right? So this would be divided by h, because the function is just x squared. And then how would I compute this limit? Well, you can just expand x plus h squared and find out that so what you're going to get, well, I mean, there are two ways of really doing this. One is I can actually factor out the numerator. Can someone see how to factor out the numerator? It's like having a squared minus b squared there, right? So isn't that the same as a minus b times a plus b? Right? So if you factor out the numerator, what would you get? What is x plus h minus x? X plus h minus x is h, and then x plus h plus x would be 2x plus h, right? You agree with that? So this thing divided by h is what I'm going to get if I factor out. Did that make sense? And then I can cancel out the h's. I could have just expanded this. x plus h, multiply by using FOIL and simplify, and I would be getting the same answer. But I factored out, there is a reason why, and then this is going to be what? This is going to be just 2x plus h here, and then the limit turns out to be what? 2x. So what we found is that the derivative of x squared is 2x. Is everybody okay? If I look at the function f of x to be x cubed, what's going to happen then is that the derivative would be, again, the limit as h goes to 0. This time, what do I get? What's the value of the function at x plus h? It would be x plus h cubed, right? And then you're going to subtract the value of the function at x divided by h, right? This is what you get if you take the limit this is what you get for f prime of x. How would you compute this limit again? Again, you can multiply x plus h 3 times, okay? And simplify everything down and do it that way. Or let me tell you that if you have the difference of two cubes, it is equal to a minus b multiplied with a squared plus ab plus b squared. Is that making sense? So I can factor out a cubed minus b cubed in this way. Notice that the second factor that I have here, I start with a squared, and then I decrease the power of a, and I'm increasing the power of b up to 2. Is that making sense? If you look at this guy here, I started with a squared, and then I'm decreasing the power of a. What's the power of a in the last term? 0. And I am increasing the power of b. The power of b in the first one is 0. Okay? So keep that pattern in mind. Now, if I apply this, what's happening? Well, for me, I'm going to take A to be this guy, okay? And B is X. So for us, A is X plus H, B is X. So if I apply the formula that I just gave you, what am I going to get? A minus B would be the same as H, right? And then I'll be getting X plus H squared plus X plus H times X plus X squared, right? You agree with that? And divided by H, and then H's cancel out, right? And now notice what happens if I plug in 0 for H, right? What happens when I plug in 0 for H? Now, what do I get here? If I plug in 0 for H, what do I get? What do I get here when H is 0? So how many X squared do I have? So I get 3X squared. Is that making sense? So I am going to do one more, and then I'll tell you what's the rule. If I have f of x to be 4, okay, then the derivative in this case, well, you evaluate the function at x plus h, which would give you x plus h to the 4, and then you subtract the value of the function at x divided by h. Now this time, how would you factor out the numerator? Well, exactly the same way. Oh, this is actually 4 there, right? Yeah. That's actually 4. And so how would you factor it out? Well, you still take x plus h minus x, which would be h. And then you start with the x plus h cubed, and then you decrease the power of that and increase the power of x. So it will be x plus h squared times x plus h times x squared plus x cubed. So that's what you're going to get. And now I can cancel out the h's, and what do I get then? If I now plug in 0 for h, what do I get? I get x squared x, which would be x cubed. X cubed. So what's the total? 4x cubed. And I guess you see the pattern now. I can keep doing that. I can look at actually 5, actually 6, 7. I can keep factoring out this way. So generally what is happening then, notice that what's happening generally is that when you are taking the derivative with respect to x of x to the 4, what happened is basically this 4 came out and came down as a factor, and then you subtract 1 from the exponent, right? So that's what happened when we took the derivative in each of the above examples, okay? So generally what's true then is the following, that for any positive integer n, the derivative with respect to x of x to the n is equal to n x to the n minus 1. I'm using the brackets here. You shouldn't use parentheses here, okay? Because if you use parentheses here, it usually means that you are evaluating the derivative at a number, okay? So when you're writing brackets here, it means that you're taking the derivative of that function. Okay, so So this is known as what? This is known as the power rule. And now we can easily compute, for example, the derivative with respect to x of x to the 101, and we know that it should be x to the 100 here. Is that okay? In fact, we can say so here I stated the power rule in terms of only positive integer exponents, but in fact it doesn't have to be. So the general power rule says the following: the derivative with respect to x of x to the r is r times x to the r minus 1 for any r, so for any real number r. Okay, we can in fact say that. So for example, now I can take the derivative with respect to x of x to the 1.01, and then that would be 1.01 times x to the what? 0.01. If I take the derivative with respect to x of x to the pi, this would be pi x to the pi minus 1. Okay, so the power, so we know how to take the derivative of any power of x now. Okay, everybody is clear on this? Okay, here is another theorem for any constant c, the derivative with respect to x of c is 0. Okay, the derivative of a constant function is always 0, and that should be obvious, right? If you think of the derivative as the slope, what's the graph of a constant function? The graph of a constant function is just a horizontal line, right? So if the graph is like this, so let's say this is the graph of the constant function c, then what's the slope of the tangent at any point? The slope of the tangent at any point is 0, right? Because it's a horizontal tangent. And so the derivative everywhere should be 0. Okay, so for any constant function c, the derivative must be 0. Here are some. Here is a theorem that's going to allow us to take the derivative of a sum of functions if we know the derivative of the individual summands. Number one, the derivative of the sum of two functions, f of x plus or minus g of x, that's the same as the derivative of the first summand plus or minus the derivative of the second summand. So what this is saying is that if I have a sum of functions then I can take the derivative term by term. Okay, and there is an underlying assumption here for this to work. This formula works as long as the derivative of f and g exists. Both the derivative of f and g exist at x. Then this formula works. So the way I should say it is that if the derivative of f and the derivative of g exists at x, then the derivative of the sum will exist at x as well, and this is how we can find it. Number 2, for any constant c, the derivative with respect to x of c times f of x, well, what this is going to say is that you can factor out the c outside of the derivative, and well, let me just, instead of writing that, instead of writing d dx of f, let me just say f prime of x. Okay, so what it means is that to take the derivative of, let's say, 3 times f of x, all we have to do is take the derivative of f and multiply by 3. Okay, so the derivative of c f of x is c times f prime of x. Once again, the way I should be saying it is that if the derivative of f exists at x, then the derivative of any multiple of f exists at x as well, and it's given by that. Now, what this is going to allow us is, it's going to allow us to take the derivative like this. Let's say I have this following function f of x, which is, let's say, 5x cubed plus 2x squared minus 3. Okay. So what's the derivative of this function? Well, by applying the sum formula that I gave, the number 1, this would be the derivative. So I can take the derivative term by term, first of all. I can take the derivative term by term. So I get the derivative of the second term, and I can take the derivative of the third term. Now, the second formula above says that I can write the derivative of 5x cubed as 5 times the derivative of x cubed plus 2 times the derivative of x squared minus the derivative. I'm not going to do anything with this. I'll just keep it as derivative of 3. Now we are going to apply the power rule. By the power rule, I know that the derivative of x cubed is what? 3 x squared. The derivative of x squared is 2x, and the derivative of 3 is, well, actually that was a negative sign, which doesn't really matter in this case. So at the end we are getting what? 15x squared plus 4x. Now, before any of you ask me, let me tell you that if you can answer this question in one line, that is, if I ask you to find the derivative of this function and if you give me only this line, that's fine. Okay? And in fact, that's what I hope that you will be able to do after some practice. Okay? So once again, if you write this line, that's fine. You don't have to write the intermediate steps. The reason I wrote the intermediate steps is to show how Formula 1 and 2 are applied. Okay? Is everybody clear? So once again, if you have a sum, you can take the derivative of one term at a time. and then anytime you have a constant factor in front of a function, you can factor it out and take the derivative of the rest of it. Okay. Any questions so far? No? Here's another example. Suppose that I have the function which is given by 1 divided by the fifth root of x to the 9. How would you find the derivative? How would you find the derivative? Yeah, you rewrite it as just a power of x, right? How would you do it? Well, first of all, it is x to the what? 9 fifth, and then that's the same as actually what? Negative 9 fifth. And so by the power rule, what do I get? Negative 9 fifth x to the negative 9 fifth minus 1, right? You subtract 1. So what is that? Negative 9 fifth x to the negative 14 fifth. Okay, so that's the derivative. Is everybody okay with that example? Everybody's okay? All right. So here's the product formula. Product formula. So what is that? If you have the product of two functions f and g, and we want to take the derivative of the product, how do you take the derivative of the product? Well, one would expect that this is equal to just like the sum rule. You just take the derivative of each factor separately and then you multiply them, right? That's what one would expect, but in fact that's not true. So the derivative of the product is not just a product of the derivatives. What's the product? Well, it looks a little bit more complicated. You take the derivative of the first factor, you multiply by the second factor, plus you do the opposite. You have the first factor multiplied by the derivative of the second factor. Okay? So that's the product rule. Once again, the underlying assumption here is that the derivative of f and g exists at x. Okay, so let's see how this is applied. Let's say I want to take the derivative with respect to x of x times 3x plus 1. Well, let's say 3x squared plus 1. So I have the product of two functions, right? Here, what's the first factor? The first factor is just x, and the second factor is 3x squared plus 1. So by using the product rule, what can I say? I can take the derivative of the first factor, right? Multiply by the second factor as it is, plus the first factor multiplied by the derivative of the second factor. And what do I get? The derivative of x is 1, so all I get is 1 times 3x squared plus 1. And what's the derivative of 3x squared plus 1? The derivative of 3x squared would be 3 times the derivative of x squared. Derivative of x squared is 2x. So I get 2x here. And what's the derivative of 1? 0. So basically what I get is 3x squared plus 1 plus 6x squared, right? So what's that? 9x squared plus 1. So this is what I get by using the product rule. However, notice that applying the power rule here in this problem is actually harder way of doing the problem. Notice that I could have done this problem in an easier way if I multiplied first. So let me just redo that problem again. We are trying to find the derivative of x times 3x squared plus 1. And I could have just multiplied first, and I would have gotten 3x what? Cubed plus x. And then by using the power rule, this is what? 9x squared plus 1, right? So if multiplying is easy to do, then that's what you should do, and then take the derivative by using the product rule, not by using the power rule. But sometimes multiplying would be actually more tedious to do. So let's look at an example where you should be applying the product rule instead of trying to multiply out and then take the derivative. So here's let's say you want to take the derivative of the product x to the 3 plus 2x squared minus 1. And here, let's say you have x squared plus 4x plus 2. Okay, you can still, I guess it's doable, you can still multiply out first and then take the derivative by using the power rule, but of course it takes a little bit more time to do that. Let's just apply the product rule here. So I have two factors here, and I take the derivative of the first factor, right? What's the derivative of the first factor? It'll be 3x squared plus 4x. That's the derivative of the first factor. You have to multiply that by the second factor as it is, and then plus you have the first factor as it is, and then you multiply by the derivative of the second factor. What is that? The derivative of the second factor is 2x plus 4. And that's it. Is everybody okay? You take the derivative of the first factor multiplied by the second factor as it is, plus the first factor as it is multiplied by the derivative of the second factor. Okay. Is everybody okay? Now, previously when I applied the product rule, note that I wrote these intermediate steps, right? Take the derivative of the first factor multiplied by the second. First one multiplied by the derivative of the second factor, and then I sort of showed you all the steps. But eventually, I hope that you can answer these questions in one line. Okay, so this would be. Now, if I ask you this question in the exam, should you be simplifying this expression? The answer is no. You can leave your answer right here. Why is that? Well, the reason I don't want you to simplify anymore, right? You can multiply out and so on. Why do you think I don't want you to do that? Well, if I wanted you to do that, then why not multiplying out here and not apply the product rule. Am I making sense? So that's one point. The other point is that in the exam, you don't have that much time for every single problem to get. This is what I expect you to. This is how much time I'm going to give you to answer this question. I know that it should be in 1, 2, or 3 lines. So that's how much time I'm going to give you for that problem. So don't waste your time in simplifying that expression. Is that okay? All right. Is everybody feeling okay with product rule? All right. Quotient rule. So what's the quotient rule? If you take the derivative with respect to x of the ratio of two functions f and g, then what you get is one would expect that the derivative is given by the derivative of the numerator over the derivative of the denominator. This is what one would expect the derivative to be, but unfortunately that's not the derivative. It looks more complicated. The derivative is in fact given by, you take the square of the denominator. So whatever the denominator is, you take the square of that. And what goes in the numerator is something similar to the product rule. In the numerator, you have the denominator first, and then you multiply that by the derivative of the numerator. And then you subtract the numerator multiplied by the derivative of the denominator. Okay? How many of you know how to sing this formula? Yeah. Right. You want to say that loud?
No, I prefer not.
Right. Okay, so what he said is that in order to remember this formula, sometimes the high school teachers, some of them, they will make you sing. And what they make you sing is the following. So high means the numerator, low means the denominator. So you take high, d low means derivative of the, this is low d high. So low d high, derivative of the high, minus high d low. D low means derivative of the low, and then this is what? Square root of, okay. So or you could say low or something, I don't know. Yeah. No, I don't think I will. And I am this is not that hard to remember. Okay, one of the common mistakes that I see is that this negative is switched. So these two terms are switched. Sometimes some students will switch the two terms, but the order here is important. Okay, is it clear? Is the formula clear to everybody? Okay, so let's see how this is applied. So let's say that I want to take the derivative with respect to x of x plus 1 over x plus 2. So by using the quotient rule, what we know is that you take the square of the denominator, and then in the numerator, the first thing that we have is the denominator, and you multiply that by the derivative of the You multiply that by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator. And what is that equal to? Well, that is equal to x plus 2 times 1, right? The derivative of x plus 1 is just 1. And then minus x plus 1 times the derivative of x plus 2. The derivative of x plus 2 is what? Derivative of x is 1, and the derivative of 2 is 0, so that's 1 as well. So this is x plus 2 squared. And what do I get here? X plus 2 minus x minus 1. And this is going to be what? 1 over x plus 2 squared. Is everybody okay with that? Any questions on that? So, say it again. So that's the quotient rule. Now, if I have a question like, say, y is equal to 2 divided by x to the 3/2. What would you do? Would you apply the quotient rule? You could. There is nothing wrong with applying the quotient rule. However, that's just more work. So you could actually rewrite this as what? 2x to the negative 3/2, and then you can apply the power rule. But it is okay to apply the quotient rule. I'm just saying that applying the quotient rule is in fact more tedious than applying the power rule in this case. There is another reason, which is if you apply the power rule here, you automatically get a simplified answer. But if you apply the quotient rule for a function like this, then you get something, a fraction, you have to simplify it a little bit, okay? So power rule gives you more simplified answer than quotient rule. Is that okay? Of course, there are some times that you have to apply the quotient rule. There is no way out. Okay. All right. So I'll see you on Monday.
First time the quiz you added, you will be adding or have added for today?
Yeah.
Is it time?
No, it's not.
Email if you got it, but like I have a meeting at 3, and I know that your office hours are 2 to 3
Today?
Yeah. Since I have a meeting at 3, I was just wondering, is there anything I would do?
Like, guessing you walk out.
For my,
What is it about?
For my, I want to talk to you about my exam.
Oh, you want to talk about your exam?
Since I had a meeting, I just want to do it real quick.
Yeah. You said you have a class night right now?
I have a meeting at 3. Are we allowed to do it next week too, or is it today?
Yeah, next week is fine. Because you.
Sorry.
Okay, yeah, next week will be fine. Do you have your exam with you?
Not on there now.
You don't have it right now?
It's in my room.
Okay. Yeah, so it would be better if you bring your exam with you. Well, this is what you want to do before you come though. Bring all the homeworks that you have done so far. So all the homework solutions that you wrote so far, bring those and bring the corrections of your exam.
Okay.
So correct the mistakes that you made and bring them on Monday.
All right.
And then we'll talk.
All right.
Okay.
Thank you.
Yeah.